Hi, I'm Chris Bowden and welcome to the Geek Group. This is our Project Gemini Tesla coil. It's a 10 kVA bipolar Tesla coil capable of producing discharges at approximately 1.5 million volts. That's about 10 feet long. It's powered at 240 volts through one of these. This is a pole mount distribution transformer. What we do is power it backwards. By putting 240 volts in here, we get 14,400 volts out the top. We took one of these and put it in a pretty blue box, and you can see it behind me. We'll get into more detail on that in a minute. A Tesla coil is actually a very, very simple machine. It works by having the power supply here, which is our pole mount distribution transformer, recased in this pretty blue box. Power comes in at 240 volts across these two terminals. The center is a ground reference. The output from this is a single wire at 14,400 volts. The other side is connected to ground. All this box does is increase the voltage from 240 to 14,400. To protect the transformer, we have a safety gap. Now, the purpose of the safety gap is that if any voltage across the system exceeds what the transformer is rated for, this grounds everything out. It's a voltage-controlled switch. At about 16,000 volts, this fires and dumps everything to ground. This protects the transformer, capacitors, and the entire rest of the system. The electricity coming out of the power supply is fed first to this tower of the rotary spark gap. The rotary spark gap is a very simple machine. All it is a very large, very high power, very accurate switch. The system works by having a motor that is synchronous to the input frequency. So the 60 hertz power feeding the motor controls the actual speed of the motor. It's phase locked. Because it's locked directly to the input frequency, that allows us to control when the electrodes come into presentation, which closes the switch. The voltage has to be high enough to jump the gap, but not so high that the switch is unable to break the connection. The way it works is each of these flying electrodes in turn comes into presentation with the stationary electrodes on either side. And when all four gaps are lined up, electricity can flow through the system. A moment later, the gap continues turning, and it breaks the connection and gives the transformer a chance to charge the capacitor array. Once they come back into alignment, the energy from the capacitor array overpowers the small gaps, and all of the energy in here is dumped out into the primary coils of the Tesla coil. And that's basically all there is to it. This is one of the primary coils. There's one at the bottom of each of the towers. The primary coil doesn't actually electrically connect to the secondary. It's all done through inductance. The primary coil is made in two parts. The first part is the large coil up here, which connects out on this line. This line is the other part and connects only to a simple ring around the bottom on the inside. There's an adjustable tap, which is just a jumper wire that connects from here to here so that we can control the inductance of the system. This allows us to tune the primary coils. That's one of the tuning points in a Tesla coil. The other tuning points are the capacitor and the top load. By controlling these three tuning points, it allows us to control the timing and tuning in the Tesla coil to bring everything into resonance. And that's the key. All the individual components have to work perfectly with each other for the system to operate properly. If any one of those three is out of its parameter, the system will not work. The energy from the power supply at each bang from the capacitor is brought out through the system and flows through the primary coil. This creates a large electromagnetic shock wave. The magnetic field is created in a big bang and then collapses, and when that happens, it pumps a small voltage into here. Now that voltage creates a wave, and that wave rockets all the way up, comes all the way back down, and right when it's starting off again, the next bang happens. This works like an electrical swing set. By applying a small amount of power at the right time, we're able to achieve a much higher result, just like with the swing set. The secondary coil form is actually made of a piece of sewer pipe. It's just simple PVC pipe wound with copper wire and then coated with several coats of epoxy. Everything is kept very clean, and you have to keep the whole system turning while you coat it to keep drips and bubbles out. The bottom of the secondary coil is connected to a 10-foot copper ground rod, which is actually driven right through the floor and goes 10 foot down below us. The top of the secondary coil comes off up here and connects to this large top load. This is a nice spun aluminum toroid, and that's all it is. It's a big piece of aluminum that's nice and smooth. By making it a large radius and very smooth, this allows us to build up a higher voltage before the electricity breaks out. If this wasn't here, the whole system would break out much earlier and we'd have much lower voltages. Up above the toroid, we have a breakout point. Now the breakout point for us is just a simple piece of conduit and a cast iron base. This is actually an insulator base. This allows us to control where the discharge comes from. Without this, the Tesla coil will break out all over and the sparks will move around. And they hit the cage and the floor and the ceiling and everything else. This allows us to have some small control over where the discharges go. The arcs come off from here and immediately start searching for ground or anything else. At these voltages, just about anything constitutes ground. The arcs come off here and tend to head towards the other tower. Each tower is out of phase to the other tower at any given moment in time. This is the Geek Group's Research MMC capacitor array. It is the largest MMC array in the world with 1,000 capacitors. Each capacitor is rated for 2,000 volts and 0.15 microfarads. The Geek Group built this to set a world record and to have something that we can use around the lab with just about any Tesla coil. It only takes 1/2 of this to power Gemini, and you can see it over there. This is the other half that we keep out on display. The MMC array was designed and built by Mr. Paul Kidwell and several of our local members. To allow access to the system for maintenance, we've made it hingeable, and you can open this up and access every single cap. Each individual cap is a 942C20P15K. These are the F series. The caps are arranged in strings of 10, which are wired in series. 2 strings of 10 gives us 20 caps. There are 50 strings in each array. And now, let's make some sparks.